So thanks for sticking around for the last session, and a massive thank you to Accenture for inviting me to participate today. I really appreciate it. I'm leading a team at Amazon Web Services that is focused on developer awareness, so trying to help software developers understand how they can build services using modern approaches to software development and modern approaches to operations. So that's what I and my group focus on. And obviously, one of the hottest topics in software development right now is incorporating machine learning features into applications in order to imbue applications with human-like capabilities to make software do things that just a few years ago only people would have been able to tackle. Okay, and that's what I'm going to chat to you about in this final session today. The first thing I'm going to do is just talk about how we use this kind of technology within Amazon more broadly, Amazon the retailer, Amazon the consumer products organization, and we'll talk a little bit about how we apply machine learning to build applications and services that have these unbelievable human-like capabilities that can do things that sometimes do actually seem well, pretty much like magic, like any sufficiently advanced technology, right? It's indistinguishable from magic. And I was really surprised to see that the first example I'm going to talk about, which is in our fulfillment and logistics area, was actually covered this morning in the opening keynote by another speaker. So I won't have to say that much about this example if you were here this morning. If not, what you're looking at here is a new model for logistics operations within Amazon fulfillment centers around the globe. These are the giant warehouses that hold all of the inventory that Amazon retail customers have available to purchase. And we acquired a company a few years ago, as the opening keynote speaker this morning mentioned, called Kiva Systems, which is now part of Amazon Fulfillment Operations and develops autonomous robotic systems that are capable of moving the inventory around inside these giant fulfillment centers to transform the way in which the pick and pack operations work within the facility. So we're using machine learning to optimize inventory placement within the facilities and also to imbue these robotic systems with autonomous navigation capabilities. They can see and move around inside the warehouse autonomously in a safe and fully automated fashion. As a pick and pack team member, you just stand in one location and the inventory is brought to you in sequence, with the inventory holders facing in the right direction to present whatever item you need to place for that customer's order next in the sequence. We also use machine vision at the end of the process to verify that you have the right things in the package. So we'll check whether you've got a copy of Game of Thrones Series 5 on DVD, a copy of Fortnite for the PS4, and a pair of socks. We'll verify that using machine vision. And if it looks like you haven't got one of those things with high confidence, we'll route that package off to a human being for verification. Because whoever wants to receive their parcels more slowly, less accurately, and pay more for the privilege of receiving their purchased products. Okay, so by investing in ML in the logistics chain, we can improve all of those characteristics for all customers forever. Next thing we have is in search and discovery, and this is one of the longest lived use cases for machine learning within Amazon retail. If you've used the website, you'll be familiar with this. Customers that bought this particular product also purchase these products, or you might be interested in, or we recommend for you, which appears on the homepage. It's another component there that includes a set of products that we feel might be interesting for somebody with your particular purchase history. So if you're like me, got two children, 6 and 8-year-old little girls, after Christmas, Lego friends, gymnastics, and girls' toys and books are really what I see in that feed because it's influenced by my own purchasing history, okay? But it's also influenced by the purchasing history of other individuals that have similar patterns to me. And this is what makes this quite a challenging thing to implement. Does anybody know how many inventory items are available on Amazon.com? How many different product items are listed on the Amazon.com website? Say to the nearest million items. Anyone got an idea? 26 million? No. Anyone? Over 1 billion? You're high. Okay, it's over 200 million different inventory items available. And then we have, quite a significant number of customers as well. So if you consider the table that is used to drive this is essentially a table with customer IDs down the left-hand side. That's the left-hand side. And then across the top, 200 million plus columns, okay? And every now and again, one of these intersections has a non-zero integer in it, okay? And that non-zero integer is how many times that particular customer purchased that particular product. And what we want to do is look across all of these purchase histories and figure out for a customer that has a 5 in column 95, a 7 in column 24,256, an 11 in column 52,507, and some more numbers elsewhere out in the field, okay? The next most likely column to have a non-zero number in it is column A. Okay, and to do that, we use a machine learning algorithm called factorization machines. Can make predictions about what the next most likely number in this particular matrix sequence is, okay? A very big data problem to solve, and a data problem that needs to be tackled regularly in order to keep these recommendations fresh, okay? We don't want to train the whole of our model every time we have some incremental data. So there's important optimizations there that can be made to the training algorithm that make a use case like that viable at that kind of scale, okay? And that's the kind of problem that Amazon's internal machine learning and data science teams work on day to day. So we've got a lot of experience in doing this stuff and a lot of experience in doing it over a really extended period of time as well. This feature's been on the website since, well, I remember seeing it in '97, because I'm old, okay, so it's been around a long time. But it's a feature that is incredibly popular with customers. With Netflix, their similar feature for movie recommendations, they've said quite publicly that 75% of their traffic on Netflix comes from you might like to watch this because you watched whatever's in your watch history. So it's an incredibly popular feature with customers. In the retail context, it helps us sell more, it helps make the experience more valuable for customers. And in the case of Netflix, it's about increasing the value of the subscription and diminishing the likelihood of a customer churning off and trying an alternative service or feeling like they're not getting good value for their subscription. So there's tons of applications for this in all kinds of different businesses, okay? And then we have content discovery, some stuff that's really innovative, okay? So here we have a product called Amazon Prime Video. It's part of the Prime bundle that you get in the US, UK, and other locations where Amazon offers Prime, something that you get as a de facto addition for paying for free one-day shipping. You also get access to our video service. And here what we're trying to do is enrich and improve the experience for people that are viewing video content. Viewing video content today obviously takes quite a few different forms, but one of these forms is the long-form box set style format that's been popularized by things like Game of Thrones, which I mentioned earlier. And this use case example that you can see here of the interface actually comes from Game of Thrones. If you're watching that on Prime Video, you can follow the story arc associated with one particular character. Now, if you've watched the series or read the book, you'll know there are lots and lots of characters in a series of video like this. In the case of Game of Thrones, I don't know, I'm guessing, I'd say there's well over 500 characters that appear in the story today, okay? And some of them have narrative that arcs across multiple series, multiple episodes, okay? Until they get brutally killed off without warning, of course, okay? So what if I want to watch the story of Khal Drogo or the story of Daenerys Targaryen, okay? Well, you can do that, and you can do it by virtue of a couple of features that are enabled with machine learning. Transcription, so text-to-speech conversion or speech-to-text conversion of the audio streams associated with the video content. So we can identify every place in the story that a particular character appears. Okay, and we can sequence that by time code and link it to the video assets. And also object and facial recognition. Let's pick out Amelia, the actor that plays Daenerys Targaryen, and figure out everywhere she appears in the video frame, even if she's not in dialogue. Okay? By using these techniques, we can then apply a third machine learning technique, topic modeling, which is an unsupervised machine learning technique that is capable of detecting significant topics in a corpus of text. Okay? And we can reconstruct the story of a particular character as it spans across multiple appearances and multiple mentions in a multi-part video series. Okay, and that's precisely the feature that we've delivered by combining those three different machine learning techniques within Amazon Video. I think it's pretty cool, a pretty sophisticated use case, and of course, there's a lot of science behind that. Topic modeling, it's a well-researched area, facial recognition, object tracking, audio to text conversion, very well-researched areas. It's the way in which these services are combined to create this really unique product experience that I think's worth thinking about, worth exploring. Okay, we actually have the same thing in video as well. So audio fingerprinting enables you to establish what the soundtrack is in any particular scene or frame of video. Okay, and then we use facial recognition, object detection to figure out who's in the video, link those back to actors, and allow you to jump off onto IMDb and establish what other works, what other TV series or movies might have these particular actors appeared in. So it's a really rich experience for video that is enabled using machine learning technology. And then we have, experimental stuff. Can you kill the audio, please? I don't really want the sound on here. So Amazon Prime Air. This is not a trial or a simulation. Oh, it's not a simulation, it is a trial, okay? So this is operating close to Cambridge in the UK right now. And what you're seeing here, it's fully autonomous drone-based parcel delivery. Okay, so the customer places the order. If they're in the qualifying area with a qualifying product, we have an experimental Prime Air fulfillment center. We dispatch the item, the drone picks it up, the drone takes flight, the drone navigates autonomously to the delivery location, lands autonomously, takes off autonomously, and returns autonomously to the origin location. Okay, there's no human being steering the drone. In fact, the drone does not even need cellular, Wi-Fi, or any other type of radio connectivity while it's in flight. Okay, so it can fly through areas of the countryside that are unserved by cellular or Wi-Fi service, and it can navigate on a fully autonomous basis. This is kind of interesting in a rural environment, okay, but it's very, very interesting in a built environment. Consider flying through downtown Helsinki or London or New York or LA with this kind of technology. What happens in the built environment? Change happens all the time. There's a construction crane there that wasn't there a week ago. There's a block of flats or an apartment building or an office block that isn't on a map because it's been constructed. It's not on a 3D scan, it just appears in the built environment. Maybe there's a power line or a tree. Well, the drone needs to be able to autonomously avoid that. And to achieve that, we use actually very similar technology to the kind of technology that you might have seen running on our demo out in this expo area here earlier today, which is video-based analysis with object detection and tracking. So we can observe where the buildings are, we can figure out where the landing zone is, we can avoid trees and power lines and telegraph poles as we fly in, and we can safely land on the target regardless of what obstacles might be introduced into the built environment since the last time we were there. Okay? Power consumption is key, and manageability is also really important. Every time the drone comes back to base, we have an opportunity to redeploy machine learning models and firmware onto it. So we need infrastructure to manage the OTA deployment of machine learning models and firmware onto the devices in a controlled way with large-scale fleets. You know, in the future, there could be very, very large numbers of these devices that have been built and that are operating in various locations. So there's a whole lot of cloud-based infrastructure that manages deployment and control of the devices as well as the machine learning going on the physical flight components. Okay. And then we have this. When I was talking about systems that feel kind of like magic, this is a really good example of that, the Amazon Echo. It's a wide spectrum voice recognition and natural language understanding system. Okay, so I can speak to it actually in several different languages now. English, that's American English and English. Okay, those are actually two different models, believe it or not. English with an Indian accent, Japanese, German, and there are more on the way, okay? But we might even have launched more already that I don't know about. There are definitely more on the way, okay? So, automatic speech recognition, you said, what time is the next flight from Helsinki to London, okay? So that's converting those audio forms that my ear picks up into tokens, text tokens that can then be processed by something called an NLU engine, a natural language understanding engine. Because what time is the next flight from Helsinki to London is the same as when's the next time that I can fly to London from Helsinki, right? But the words that describe that same intent can vary. In fact, they can vary really significantly. It's not a overstatement to say that there are hundreds of thousands of different ways to express exactly the same intent in English. So the NLU engine allows us to have what on the face of it appears like a single shot intent resolution and entity extraction capability, so we can figure out what the customer wants and also extract the pertinent entities from the utterance, in NLP terms, from the fragment of text that are important in order to fulfill the transaction. And then we can look up whatever's been asked for in an information source and return an answer to the customer, render it back into audio so they hear it in a length of time that makes it feel natural, a length of time that makes it feel like you're asking a person in the room rather than asking a giant distributed information system, which is actually what's happening in the background. So when I say, Alexa, what's the weather going to be in Helsinki this week? It can figure out the intent is know the weather, the target is Helsinki, and within a few single-digit hundreds of milliseconds, it can say, on Monday it's going to be sunny and 19 degrees. On Tuesday it's going to be partially cloudy and 17 degrees. And on Wednesday it's going to rain. Okay? And it does that fast enough for it to be a completely natural experience for me. There's a lot of computer science and a lot of machine learning smarts behind that. Developers in the room probably already know this, but if you don't know this, you can extend the platform, you can create your own intents, you can train your own intelligence into the machine learning engine, the Alexa voice service, and you can deploy your own applications onto this voice platform, which are called Alexa Skills. And you can do that globally from a seat anywhere in the world as a software developer. Just create an account on developers.amazon.com, go to the Alexa Skills portal, and you can get up and running straight away in building rich voice experiences for Alexa. I know it's something that the Accenture team around the world have also worked on quite extensively. So if you want help, then Accenture are a partner that can help you do that. And then lastly, we have this. This is the latest innovation that we've launched to the public, which has machine learning at its core, which is Amazon Go. This is a cashier-free, checkout-less retail experience. Walk in, scan the QR code in the Amazon Go app on the barcode reader as you enter the store, remove whatever products you want from the shelf, leave the store, and within a minute, you'll receive a push notification telling you you've been charged $15 for a nitro cold brew coffee, a chicken salad, and a can of Coke Zero. And it literally works like that. It works reliably. Works reliably even when people try to game the system. Even when people come in, put a bag on the floor, put some items into the bag, take some items out of the bag, put some items on the shelf, remove some more items from the bag, leave some stuff in the bag and walk out. They still get charged for the things that they left with, okay? Even when the pranksters in our staff come in dressed as giant 6-foot-tall bananas at Halloween time or wearing orange suits, it still works. It's still very reliable. Object tracking, sensor fusion, and this just walk out technology, which makes for this friction-free retail experience. Once again, creating something that is really simple and compelling for customers to use requires a lot of science. It requires a lot of machine learning capability, and it requires innovative approaches to problem solving as well. Okay, so Amazon Go. If you're ever in Seattle, just go to Amazon Go and check it out. It's a really simple experience. It's open to the public right now. It's the actual facility in downtown Seattle. So that's what Amazon has done with machine learning. What are we trying to do with machine learning at Amazon Web Services? And as you know, at AWS, our primary constituency of customers are software developers and product builders, okay? IT operations professionals and IT pros as well. So we're trying to get technology into the hands of software developers, product builders, of IT pros that makes it easier for them to build really compelling applications. It also enables them to transform and modernize the way in which they run existing IT, okay? In this case, we're more focused on new applications or adding new features to existing apps. And really what we're trying to do with machine learning at AWS is exactly what we tried to do with basic computing primitives back in 2006 and with storage back in 2006, which is fully democratize access to these capabilities and make them possible for any person that wants to use them to access just by entering a credit card number and then using one of our APIs, one of our software development kits, or one of the services that we provide that abstract those things. Okay, so you have really simple access to the components that you need to build applications just like the ones that I've talked about that have been built within Amazon. Okay? And it turns out that even before we started focusing on this as a dedicated focus area within AWS was already something that a lot of customers were using us for. Why? Because we have low-cost, high-performance, on-demand computing resources that developers could use with their own expertise to build and train these machine learning models. And the usage pattern, the characteristics of usage in machine learning have very, very high affinity to the kind of characteristics that the cloud provides. I want to train a model, and for deep learning, what that means is I need to do large amounts of floating point operations around a data set. Okay, I need to do lots of maths, and when I've done all those maths, I get an artifact, which is a predictive model. I can give that artifact, that predictive model, new data samples, and get back predictions about those samples. The model might not be optimal. The model might not work. So what am I going to do? Tweak, change, and then train again. And then train again, and again, and again, and again, until eventually I iterate to a model which is effective, efficient, it has efficiency for my particular use case, all right? So that means that I've got a big spike of computational activity, which is when I do my training. If I can apply a ton of computing power to that, I can get through those iterations more quickly, I can evolve my products much more rapidly, and I can build much better machine learning capabilities with unfettered, unrestricted access to large amounts of resources, okay? So that's one of the reasons there's affinity. The second is, although that's a big workload, the real primary workload for machine learning use cases is inference, so making predictions about data samples that occur after I've built the model. If I wasn't going to eke out repeated value from the models, it wouldn't be a cost-efficient use case for me. I need to get back the cost that I've spent on training the model by repeated value realization from using it, right? Okay, so there I have likely a long continuous period of inference where I'm using that trained model to get predictions. And that varies according to how much my app is used over time. Maybe I've got a cyclical model where my application is used extensively at certain times of the day or week. Maybe I'm using it for batch-based predictions with large data sets that I bring in for, say, marketing campaign predictions. So that's a spiky workload as well, and again, that has really high affinity to the cloud. So lots of users chose AWS to build these applications before we really started thinking about it as a discrete set of services. Now we do think about it as a discrete set of services, and it turns out there are multiple different types of persona, multiple different types of developer, multiple different types of product builder, and also other categories of users that have an interest in leveraging machine learning and making use of machine learning. So for this, we have to think about the space in several different ways, and this is how we break it down, okay? So the first thing is frameworks and interfaces. These are all popular software tools, frameworks, programming languages, abstraction layers that developers with expertise in this area will use today. TensorFlow, MXNet, PyTorch is Facebook's open source machine learning framework, and then there are other tools as well like Gluon, which is a portability framework for machine learning model declaration that allows you to port them across different engines actually. So experts know about this stuff. Does any of those terms mean anything to anybody in this room? TensorFlow, probably a few of you heard of. Maybe PyTorch, the rest a little bit more niche in their usage, but believe me, they all have significant application in the field. So what you guys need if you're expert in this stuff is you need high-performance computing resources, the fastest, highest performance, lowest cost machines that you can get to allow you to compress down the iteration time on building and experimenting with new machine learning models using this tooling. Okay, and for that, we have these P3 instances. These are supercomputers in the cloud. Okay, they aggregate together large amounts of FPU capacity, floating point capacity. Just like the rigs that your kids or you might have in your gaming machines at home with your NVIDIA Titan X Pascal GPUs, if you're an addict like me, or maybe something a little bit less esoteric if not. These have FPU pipelines in them. They have massive amounts, more than you could ever use for rendering graphics, really good for calculating convolutional and recurrent neural networks. So we use those, okay? And then we have a software build that packages up the software that is commonly used in this domain to make it really accessible. So I can start my machine, and it comes preloaded with all these software tools that I've talked about already on it and ready for me to get started with as a developer. No maintenance, okay? All the drivers are there, all of the packages are there, spin up the machine, log in, and immediately start working with TensorFlow or other tools that are relevant to my use case. And then we have new things like Gluon, portability framework. I can write the structure of my neural network using a declarative language, and I can train on a variety of different engines, MXNet, CNTK, and we hope to support other deep learning neural network engines in the future as well. Simplifies the development process by providing another abstraction layer. And there'll be more to come on this front in the future as well. So that's about tooling for portability of machine learning development skills. Then we have developers that have expertise in software development, but aren't experts in any of the things that I just talked about. Okay? And here we have a couple of things to try to simplify the process for them. SageMaker is a tool that makes this difficult and time-consuming process something that is much, much more accessible to software developers, okay? And the way we do that is by breaking down the components of the ML process and focusing on each of them in turn. What we're trying to do here is provide an end-to-end tool chain for developers that are interested in training their own custom machine learning models based on their own data sets. Okay, so I have annotated data and I want to train a custom model. It might be something like vehicle part recognition was a use case that I was talking about earlier on, where I'm manufacturing components for vehicles and I want my service technicians to be able to identify them just by pointing a smartphone camera at the component. Okay, so as the manufacturer, I've got domain-specific labeling information, photos or renders of the components, plus information about what each component is, right? I can combine those two things together. I could train a custom neural network using that data, enable me to predict what a part is by showing it an image of a part. The most likely component is an alternator or a particular derivative of a particular manufactured product that I make. So that's a domain-specific use case. And SageMaker enables you to do this, and it does that by taking the repeated steps in the process and turning them into tools. Okay, so the first is a data manipulation workbench plus access to optimized algorithms. Then you have the capability to train at scale, okay, and to do this on a parallel or recurrent basis using automation. So what I could do here, for example, is train large numbers of models using different training parameters, okay, enabling me to search for the model which is the most effective for my particular use case. And we can use randomized search here, train 100 or 200 models with different variations on the tuning options that are available, and pick the one which is the best. Okay, that's actually something that you can do with the service, and you can do it automatically and at really high scale as well. And then lastly, deployment out into production behind pre-configured API endpoints which have authorization capabilities. So here I can easily create that long-term inference capability that I talked about, and I can create it in such a way that it's both elastic, so it scales in accordance with demand, and it's really easy to integrate with applications that I might be building in other programming languages, whether those are mobile apps written in C or Java running on Objective-C or Java running on a handset, web applications written in Node, or more traditional back-end apps that I might write in .NET or Python, for example. I have flexibility to integrate with these endpoints using different SDKs that we provide for all those different programming environments. So it makes it really simple for me as a kind of generalist software developer to integrate these sophisticated machine learning capabilities directly into customized apps that I'm building. Okay? So we're trying to focus on simplifying the access process. Okay? We've also invested in optimizing the algorithms that are used to improve performance for things like streaming training or incremental training, like that recommendations use case that I talked about before, where I already have a lot of historical data, and I don't want to train my model from scratch every time, do I? I want to update my model based on what I've learned in the last 24 or 48 hours. And we've optimized many of these algorithms to enable them to do that when previously they couldn't. When previously you would have had to do a complete retrain, now you can do these incremental trains to make your models more efficient over time as you learn more. Lots of customers using this today across all kinds of different domains. And then the last area that we have are super simple to access pre-trained models that are made directly available to customers using those same kinds of APIs that we have within SageMaker API endpoints. So what I can do here are things like image recognition. I can send an image to an endpoint. I can call a particular action, and that action will activate a prediction against that image using a particular type of model. This enables me to do things like classify images. Does this image contain an aircraft? Does this image contain a boat? Does this image contain a human face, for example? Or facial analysis. Is this person happy or sad? What sort of age are they? Are they male or female? What's their expression? Okay, so I can do all this kinds of stuff with facial analysis. Also, celebrity recognition, image moderation, facial comparison. Is this the same person as this person, for example? They're all features within recognition. And we've got lots of customers using this as well. Things like Pinterest, with the visual image search within Pinterest, which a lot of you have probably seen or used. It's actually powered by this kind of service. Also in C-SPAN, they are cataloging, there's a lot of this material, the US political system. Did you know it has over 100,000 politicians in it? I discovered yesterday that would be 1/6 the population of Helsinki, just working in politics in the US. Okay. And C-SPAN, they provide access to political broadcast material, and they use this service to catalog and index video content to provide better transparency. I can see every piece of video where my senator or my congressman representative appeared and represented me in the legislature. Okay, it's done automatically using facial recognition technology with this service. Same for video. Okay, I can do the same kind of stuff on video. And then additionally, in the languages area, we have quite a few services here. One of the most popular and heavily used is something called Amazon Poly. This is for audio generation. We actually support, I think, all of the Nordic languages. Certainly Icelandic, Norwegian, and Danish I've seen in the console. I'm pretty sure Swedish and Finnish are there as well. And what you can do with this is generate lifelike audio. Okay? And it really falls into two different use case categories. Creative content. So I want to voice an audio book or voice a video. It might be for training or maybe a cartoon or something that I'm actually creating as a creative work. I can render high-quality spoken audio in any of these languages using a variety of different voices with this service programmatically. I can also use it for content accessibility, for making content available to people that might be visually impaired, or for voicing an interface. Maybe I'm building a product where I want the product to speak, okay? And maybe I want to test a variety of different language options, and maybe a variety of different voice interfaces for that particular product. And then once I've validated which is the most usable, then I can choose to get a human being to voice them with a particular voice that matches my brand. But you can also use this in that kind of prototyping context to make your content, your applications available via voice-based interfaces. A really powerful service, and one that, again, is really widely used amongst customers as well. One of my favorite use cases for this actually is this RNIB. It's a non-profit in the UK supporting people that are visually impaired, and they use this service to provide on-demand transcription of content. So if I'm visually impaired and I can't access a magazine or a publication that I want to read, they'll transcribe it for me on demand to audio and play it to me for a very low subscription fee, which is actually in a lot of cases paid for by a local authority or other governmental organizations. So there's a really interesting use case there around accessibility for content as well. So that's all I have for you. If you want to learn more about any of this stuff, just hit ml.aws in your browser, and you'll find a lot of information about use cases and tools that I've talked about. You can also find me via email, just at enm@amazon.com, and I'm happy to make connections or do any follow-ups that you might have on this topic as well. Thank you.